who are slightly envious of the fact that we have a man here who makes his living out of creating iconic structures. And also the fact that you have an artist who managed to give up working in IT, which I've always thought sounded a bit like a death sentence, as for the alternative of working in Lego, which is just, what a remarkable way to make a living. And well done you for carving a unique niche for yourself, in being certainly the only person I've ever heard of who actually makes a living out of building large buildings in Lego and manages to export that throughout the planet. So good on you. And the fact that you're based in Edinburgh is very beneficial for us, because he will be heavily lobbied towards 2016 to build a few iconic Scottish buildings, or buildings that we consider to be iconic. We've just had a brief discussion about how Edinburgh Castle is not iconic. Now, as a Glaswegian, I completely concur with that view. The Glaswegian description of Edinburgh Castle, a tenement on a rock. But I do get the point that there are certain buildings which actually declare themselves internationally as being of their place, and therefore you made the point that the Forth Rail Bridge is clearly a Scottish icon, something that does export its image and is immediately identifiable or for what it is and where it represents. Your first important book, which we reviewed, I hope not too begrudgingly or ungenerously in our magazine, we suffer from honest reviews. So apologies if there was a slight downside. I did note there was a sort of slightly negative tone about the fact that some buildings don't lend themselves to Lego, which I find quite extraordinary. I was contemplating earlier, and in fact one of our major issues with the ever-present BIM word is the lack of Scottish manufacturers who actually have got ahead of the game with BIM and created BIM-ready packages for their standard, whatever they may be, building components. And I was contemplating the fact that probably Lego has. So, we can all start constructing, new facilities out of Lego, because it will be the only BIM-receptive medium that we can actually use. So they're going to have to use some more bricks for the Borders District General Hospital. 72 of Warren's models are currently on display in Paisley Museum, which is a great museum, and those who haven't visited Paisley Museum should certainly get along, not least for Warren's models. And he's made any number of iconic structures, all of which doubtless you will see during his presentation. Brick City, sitting up there, just perfect time of year for us to promote this at a proper discounted price, and you've got the man here to sign it. So, anybody who wants a present for brother, sister, offspring, to John, signed by the man himself. I mean, it's bound to be double the price instantly. So please contemplate buying your book at the end of the session, and these guys here, I'm sure, will be more than happy to sell them to you. And we've also, just today, got in our various Lego models downstairs. So again, if anybody wants to take home some architecture for Christmas, because I know you don't get enough of it in your daily lives. I'm going to hand over to Warren, thank him again for coming to the Incorporation and for joining us for this, the second of our lunchtime lectures. And I was saying to him, this is a select group, but a very appropriate select group, because all of you who I know round the table are exactly the right sort of people for you to be preaching to and communicating with, and they will be apostles for what you do and go forth from here to way beyond Paisley. Incidentally, has Paisley got an icon?
It has a few icons. I'm putting in, actually next week.
It's got the dome of the school.
Yes, next week there's the Russell Institute, the Abbey, the Arts Centre, and another building I'm putting in for them as commission pieces.
Fantastic. So, the Russell Institute by Steele? Was it Steele did the Russell Institute? I'm showing my ignorance. Anyway, I've said quite enough. I'll hand over to Warren. Thank you very much.
Thank you. Right. I was asked to kind of talk about what Lego can teach teach us about architecture. I'm pretty sure there's nothing I can teach you about architecture. But I'm going to throw it around a bit as well and sort of say what architecture can teach us about Lego. I'm also going to turn my phone off because I'll read it. This is me, Warren Elsmore. I am delighted to introduce the author of Brick City, which is sort of an architectural, it's a celebration of architecture and global icons around the world. I'm a full-time artist in Lego bricks, quote unquote, so I spend my days playing with Lego every day. Or I'd like to at the moment. I spend most of my days in meetings and organising things, but that is my job, is to build things out of Lego and to coordinate with people. Building art pieces, doing interactive pieces, for kids, for adults, for the public, private. It's very, very varied, but there's always a sort of theme of Lego through it. I am based here in Edinburgh. I have a studio down in Newhaven, and I have 37 years of training, as I like to put it. I will start with an apology. I'm not an architect. I have no architectural training. I have no engineering training. I have no building training. I know very little about architecture other than what I've read, what I've seen, and what I like. So I mean, obviously from the book, you can see that I have an interest in architecture. I do like good architectural structures. I have absolutely no training in it though. So I will possibly be teaching you to suck eggs, but I hope not, because I've based all this on the Lego side of things. That's as close as I got to architectural training, which is actually my father's college dissertation, which I read and actually found very, very interesting. I think it was on sort of church architecture and things like that. So that's about 51 years ago, he tells me. And that is as close as I've got. So a little bit of an apology, but hopefully what I'll do is I'll take through a bit of a story. We'll look at the past and sort of the history of Lego, where Lego's come from, interaction with architecture there. We'll spend most of the time on the present, on what I do, the sort of techniques I use, things I've found that I think will have would chime with what you do in your day jobs, and then a little bit of a look towards the future as well. This isn't a big group. There will be time for questions at the end, but if you've got pertinent questions that are buzzing you, just shout them out. I'm really happy to do that as we go along, because it doesn't matter too much. So, we'll start with the past, and this is where we start, 1951. Just as a little bit of background, the guy at the top there is a guy called Ole Kirk Christensen, who was the founder of the Lego company. He was a carpenter by trade. So in the 1940s, 50s, and slightly earlier in the Depression, he was a carpenter going off building houses and various things, which didn't work out very well during the Depression. There was a big drop in the demand for house building, so he didn't have that much to do. Later on, this picture is from 51. His son, Gottfried, and his grandson, Kjeld, are still involved with the company. Kjeld Kirk Christensen is still the major owner of the Lego company. It's still a privately held company based in a tiny little town called Billund in Denmark, which is, I lovingly describe it as like Slough in Suffolk. It's not a place where I spend a lot of time. But one of the things that is there is Ole Kirk's house. So this is a house that Ole Kirk built, the house that Ole built in Billund in Denmark. This is one of the last houses that he actually built as a carpenter himself. If you don't believe me, that's the real thing. With the beautiful 1970s concrete extension that the Lego Group put onto it, which literally is just a big square block. So he moved from house building, when that didn't work too well, into toy building, and it originally became a Lego. Lego toys were made of wood, so the original early Lego toys were wooden toys. If you've got any now, hang on to them because they're really quite expensive. He then moved from the wooden toys into plastic toys and into these things, Lego bricks. This was patented in 1958, this Lego brick. And the part that was patented is actually the tubes on the underside, which is what gives them the clutch power. It's what makes them stick together nice and strongly. So that patent was granted in 58, ran out 50 years later in 2008. So it's now able to be copied by a vast array of manufacturers. But Lego is still the market leader in what they do in terms of building blocks. One of the other things that they did do, though, in the 60s was a thing called Lego Modulex. Has anybody heard of this? So these are, I'll pass them around. Actually, I've got one of each. So there's a Lego brick, and then the smaller one is a Modulex brick. Now, obviously Ola had this history of house building, and one of the things that he wanted people to be able to do was to design their own house, to have it then be built by an architect and a builder, and design the house in bricks. So what they wanted to do is design the house in a Lego brick style. Now, you'll notice those two bricks you've got, A, don't stick together, but B, they're not multiples of each other, they're actually different geometries. So the big one, which is the Lego brick, is the standard geometry that you would know, and it's a brick is 3 plates high and 5 plates sideways makes 2 studs. So it's kind of a 3 to 5 relationship. The smaller brick is actually made, it's a modulax brick, and that brick is made to the ratio of a real brick, or at least a real Danish building brick at the time. So you can take those bricks and you can actually build a house with them, and then hand the model to a builder and say, build me that one. And I used 4,000 bricks there, so it'll use 4,000 bricks there. That was the idea behind Lego Modulax. To be honest, it never really took off. I don't know why it took off. I presume because people didn't want to build just square, blocky houses with only one angle of roof and only one type of window and things like that. But what it did do is it moved into a thing called plan copy, which, has anybody seen any of this? This went on till about sort of mid to late 80s, just into the early 90s. What they did is they took the modulax bricks, and rather than building houses with them, used them for signage. So you have big, as this is, big boards of bricks, or big boards of sort of studs stuck on the wall, and they had the bricks put over the top of them to create instant signage you can move around. And they came out with lots of bricks that were printed with letters and numbers and things like that. Also really good, I think this is meant to be a Gantt chart, or something similar to a Gantt chart. So really good for planning, and good Gantt charts. And in fact, companies still do that now. Every so often there's always a news story that pops up where companies use Lego bricks to do, to visualise the planning process, either on a wall or on a table or something like that. So it's still around now. But plan copy didn't last either. Plan copy really went out of business in the 80s. The Modulax company still exists as a signage company. In fact, a couple of the buildings in Billund are now named after different parts of the company. So there is a Modulax building, even though it's got no Modulax in it, it's owned by Lego. So you can still buy Modulax signage, but it won't have anything like that on it. What does still exist? There's a couple of ranges that aren't very well publicly known. There is a Lego education range. So there are sets specifically designed for education from, I don't know what the classing levels are, sort of 4 up to 15, 16, these sets are only available to schools, and quite a broad proportion of these are around community, so you get a community workers set, or a town planning set, or there are various things around the communities that the schools are based in. So part of that architectural heritage has kind of fed through. Obviously, as these sets get older, they go into the robotics and things like that, but the basic parts are still there. And the adult market also still exists to an extent. There's this program called Lego Serious Play, which is purely aimed at sort of workplaces. So a serious play coordinator will come into your workplace, and it's one of those sort of team building exercises, or one of those exercises to work out what's going wrong in your company, what's going right in your company, how you can progress things. And the coordinator would actually work with you you get a big pile of bricks and you build something maybe that represents your experience within the company, or your passion of what you want to do, or something like that. And it's used to bring out ideas and things like that. So some of those early techniques and ideas from Lego still exist, but sadly most of it, from a core kind of level of architecture as a Lego product, has gone. However, what I'm doing is, it's still very, very much in the forefront. So here in the present, I'm still doing things with Lego that I hope to continue, which are all very much architecture based, because that's my passion. So what I wanted to do is kind of run through, I had a thought about, what we were going to talk about, and I wanted to run through some of the things that I do when I'm building a Lego model and some of the challenges I have. And I'm hoping that some of these will ring true in terms of real building, or the opposite will happen, and there'll be some complete disconnects between how I have to work in my medium and you're working in real life buildings at a real scale. The first of which is planning, because obviously the planning process of building anything is very important. If you don't plan, who knows what you're going to get out the other end. And I have to do a similar amount of planning, or it's a similarly important part of my process as it is for you. Now obviously you have blueprints, I have some sort of blueprints too, but these are not, I mean this is a Lego set that you can buy from the shops and gives you an idea of what to do, but the work I do has nothing to do with actual instructions. I don't build from instructions, I'm generally building, free building from scratch with no instructions, or I'm planning something, creating my own instructions and then building that as well. So the planning process for me is slightly different. There's a couple of kind of famous interactions. There's this model which was done by Tony Kettle, who designed the full curve wheel. You're all aware of the full curve wheel. Right? When he originally pitched this to whoever it was, British Canals or whoever, they couldn't understand the fact that it was going to work, the boats wouldn't fall out. So he went home, his daughter was playing with some Lego bricks, he pulled out a few bricks, made a very, very simple model in Lego, so he could actually take it back, put it on the desk and go, that's how it works. And when you've got to see a physical model in front of you, you can't dispute the fact that it's not going to fall over. So there's a few examples of architects using Lego in the process, but I tend to flip it around the other way. And this is one of the models I'm probably most famous for, which is at St Pancras Station. It's just shy of 2 metres wide. It's about 4 metres long, which gives you an idea of scale. Lengthwise, it would fit on this table, but it's wider than this table. And obviously, that model has quite a significant amount of planning involved. I can't just sit down with a big box of bricks and build that model. It's not going to work. And there's a whole bunch of reasons why. But when I'm planning a model, I start in pretty much, I think, the same way that you would do. Is I have an idea, I have some rough ideas, and then I go into a CAD simulation. Now, I don't use AutoCAD or as a commercially available CAD package. The one I use, this one here, is actually a thing called the L-Draw system of tools. And it's a community-based, open-source Lego CAD system. So the reason I use this, there is a Lego product called Lego Digital Designer you can download, and kids can use it to build their own models. The reason I use this one is it's open source, so people around the world have actually measured, and in a lot of cases it's measuring with micrometers and things like that, Lego bricks themselves, getting the geometry of the bricks themselves, and then putting those together into the CAD system as individual elements. So I can use those elements to actually prototype, as in this case, prototype something up. And I use this as a large part of my planning tool because A, it's much easier to do this with real bricks than it is with Lego, especially if it's a flat structure like this. So it's probably a bit small, but this is basically bricks stacked up on top of each other in the same way that the traditional manner that you would think of using Lego bricks. That's a very easy thing to model in CAD. So I can drop them up, I can work out what I want my window spacing to be, how many bays I want, what the floor heights are going to be, things like that. Put a rough model together in CAD to give me an idea of where I'm going with it. The other thing it will also do is it will very easily tell me how many pieces I need. And budgeting in terms of materials is probably as big an issue for myself as it is when you're building a real building, because there's a cost associated to materials. So I want to keep the cost down, because Lego is not a cheap medium to work in, and B, to keep the weight down, because my models need to be picked up and moved around. So if I build my model as a solid model with a complete floor structure and walls and things like that, it's much, much heavier. It's a model, you're never going to see inside it. Why bother? So I can run that through, and that little section, which is about that wide, about that high, has 2,378 bricks in it, without any structure. And often that's what I'll do when I build a CAD model, is it's just the facing parts of the model that I'll actually do in CAD. The internal structure I won't bother to do a CAD representation of, because the tools don't let me do any load bearing or calculations of those sorts of materials. I can build something in CAD that won't hold together. And I tend to take advantage of that fact, that I can just build it in CAD to make it look nice. Then when I build a real thing, I'll work out how it's actually going to stick together and not fall apart. So I do a lot of planning of my models as well. I'm not going to really talk about it too much, but I can from this point on them is actually go and create instructions if I'm creating things other people are going to build. So the models in the book that have instructions are all done in this way. And they're completely virtual models until I actually get some bricks out and build them. But one of the big things I need to look at when I'm talking about building a model and designing a model is scale. And I have the advantage that I can work in a number of different scales. I don't have to work in human scale. I don't have to have people inside my rooms. This is it's in the book it's down as Georgian, sort of Edinburgh Georgian Street. It wasn't actually built as Edinburgh Georgian Street. It was built from one of the Harry Potter films. Because I do public shows, and if you do public shows with kids, you have to have things that kids will recognise. So this is, I'm trying to remember what it is. It's the headquarters of one of the secret societies in London from the Harry Potter films. Can't remember what it is. The house that's looking slightly bedraggled is the one that sort of pops out in the middle of the room. And it had Harry Potter in it, and Dobby and all that sort of stuff. But it is a Georgian house. And there's a little Lego guy on the side to give you a scale. So this is a typical scale I like to work in. I call it, and most Lego fans call it minifig scale. For obvious reasons, it fits with the Lego minifig. However, minifig scale is a bit variable because minifigs are completely wrong. You know, anthropomorphically, minifigs look nothing like real people. They're about twice as wide, their heads are too big, their eyes are far too large. They don't work as real people from a modelling point of view, but there's a very good reason why they're wrong. And it's the same reason that adults are attracted, you know, adults find babies and small children in general cute, as you do kittens and puppies and things like that. It's because they have a similar set of dimensions. The head is too large, the eyes are very large on the face. You're biologically inbred to, you know, you've got biological reasoning to find that something that you should look after. And minifigs are coincidentally very similar in sorts of dimensions. So most people find a minifig cute, of, you know, of whatever type of minifig. The problem when you're doing a building scale is like, what on earth scale is it? If you do it on height, you get one figure. If you do it on width, you get another figure. If you do it on depth, you get another figure. The legs are far too short. So it's roughly 1 to 40, 1 to 50, somewhere around that sort of area. Realistically, minifig scale is whatever looks right next to a minifig. That's the kind of way we would say is we'll do a model of minifig scale that's got minifigs in it and they don't look like big giants walking down the street or something like that. But I have a lot of choices I can do. One of the things I build a lot of models in is micro scale or even sort of nano scale, which is similar to the UN building that's down there. This is a model I did for the Olympic Park for the Danish Tourist Board and Lego last year. It's about 1 to 500, give or take. Again, there are certain things in there that I've stretched. So all the little yellow coloured dots are people, kind of. You know, if they to scale, they'd be about 3 metres wide and 2 metres high or something like that. But it's a representation of the people that are in there, and most people will look at that and go, well, that's people wandering around the stadium, and all the coloured dots in the stadium is the audience watching the games. So, again, I play a lot with scales as to what looks correct, rather than actually what necessarily might be correct. The other thing that I have to worry about is I have some real limiting factors in what I'm doing. So, this is obviously the Colosseum in Rome. And when I'm building something like this, I have to look at what are the key features of the building that make it the Colosseum. Now, it's not the colour that makes it the Colosseum, that's a totally different colour to the real thing. It's not the fact that it's a concentric ring of, you know, concentric rings of stone. The thing, to me at least, that makes that the Colosseum is its walls of arches. If you have a big wall of arches in a curve from the outside, your immediate thought is something like the Colosseum. So the important part when I'm creating this model for me is that I need lots of arches to put it in there. And that gives me a specific problem because that's my selection of arches. That's it. They are all the arch parts that exist in Lego. So I can do it at, the one on the top left is the scale that I chose, which happens to be the smallest one, so the model is a reasonable size, so about that sort of size. And these are all the other different scales of arches that I could possibly do it. So I could do it 50% bigger, I could do it 100% bigger, I could do it 400% bigger, but I can't do it 450% bigger unless I really start putting a lot of extra work into it. And it can be done. This is, we did a model for the Royal Wedding, Will and Kate. We did a model of Westminster Abbey. This was done to minifig scale, so this is an enormous model. It's as high as I am off the ground, probably a metre and a half wide, 2 or 3 metres long, weighs getting off a quarter of a tonne. One of the big things about Westminster Abbey is it's got lots of Gothic arches. And Gothic arches, until last year, didn't exist in Lego at all, and they now only exist in Lego about that sort of size, which is no good for a Westminster Abbey that's that big. So we can work around these things, and in this instance you can see, you might be able to see that those arches, Gothic arches, are actually made of lots of slopes. So it's kind of approximation. There's a 30-degree slope, a 45-degree slope, a 33-degree slope. And the other thing that I will often do is take bricks and flip them up in all sorts of different directions. So each one of these arches has bricks going in 4 different directions to get the slopes going in the right direction, to give you that sort of Gothic curve. It's totally doable at that scale, but if I drop the scale down, it's not doable because I don't have the parts don't exist. So I have a lot of limitation on things like that. It really starts causing a problem with, well, at the moment, with anything that Zaha Hadid's doing. It's curvy and flowy. And they're lovely buildings, and they're great if I can build them big enough. Because I can always raster anything into Lego. You know, effectively, if you just think of a low-res graphic image, you just raster it down. I can do that in Lego. I can take any 3D model, raster it out in Lego, and it will look fine at a certain scale. But it's when you pull it down to this sort of scale, and that's that long, that doesn't do the original building any justice at all, let's be honest about it. It doesn't have the curvy, flowy lines of the original. But at that scale, with the parts available, that is the best that can be done. So, well, it certainly is the best that could be done in the time given. So, there's a lot of cases where I have to make some reasonably serious compromises to get the overall idea around. But the overall idea for this model was to show people that were coming to the Olympics what the park looked like, where they might be going to, which seating block they're in, things like that. And for that, it worked absolutely perfectly. And that's what people spent 20 days doing. It's like, oh, we were there last week. So there's a various things I need to kind of keep an eye on that do pull things in. One of the other things that I work on a lot is sort of pattern and simplification of objects and working out which are the important parts. So it's talking about the Colosseum, the arches are the important part that works, that I feel it needs to be there. Going back to this sort of Georgian townhouse, again, you may or may not be able to see it. I use a lot of repeating patterns to give impressions of things. So there are currently, a Lego brick typically has a flat gloss, shiny side. There are now Lego bricks that have sort of, we call them profile bricks. They have either a grooved surface or an etched surface that give you the impression of a different material. So there's a sort of a flat grooved surface like that. There's actually one that looks like little bricks. It's meant to look like a row of bricks, although the bond is completely wacky and it doesn't work if you overlap the bricks at all. You have to put the bricks in single stacks for the bond to actually look anything like a brick bond, and then it's got no security at all, but that's by the by. So I use a lot of repetition and pattern and things like that. So actually going back this one, which is the Petronas Towers, I've used the pattern of the windows and the floors, so hopefully it looks like the Petronas Towers. It's not got the Petronas Towers has a lovely plan view of 2 intersecting squares with half the edges rounded, and it looks nothing like that. My model looks nothing like that. But it's got the key parts in that there is a pattern of repeating floors, and they come in at certain angles. Again, it has a lovely beehive shape, but putting a beehive shape into a model as that tall is quite difficult. So I use lots of patterns and things like that, and on this model, you can probably see a sort of brick in the what we call dark tan, the London brick colour at the top. you can see that there is kind of a brick bond pattern within. It's not just a big slab of colour. And to make that, well, I actually do exactly the same thing as it does in a real building. That's not made of bricks, that's made of plates, which are a third of the height, and it's made of thousands and thousands of plates that are overlapped in exactly the same way the bricks are. So the pattern you're seeing is the pattern that will be in the ground. It's the pattern of the gaps in between the bricks. So that's a technique I use quite often, especially in this colour, because it works perfectly for London brick, to create large things that, instead of just seeing a big slab of colour across a wall, which looks slightly artificial, to actually put some pattern into it. You can get really quite clever and actually start putting graffiti into the pattern as well, with Lego as well, and build it in different colours. That's another question. So I use that in sort of larger models to give lots of detail, but often I'll go the other way as well, and really radically simplify something. So, this is a London skyline. That's London Eye, BT Tower, St Paul's, and the Gherkin. Right? Now, they don't look a lot like the real buildings, but hopefully they look recognisably like the real buildings. And as soon as I say to you that's a London skyline, most of you got what you were looking at. So you don't have to be that exact to give across the impression of things. Shard, Tower Bridge, and some random buildings in Italy. These are two of my favourite ones, actually, that did go in the book. The O2 and Canary Wharf. Now, actually, the O2 is a good example of something that you can't build, because actually that works in camera, but does not work anywhere else at all. It's a complete bodge of the way it's photographed. But it's about 8 parts. But it's the O2. Yeah. So you can radically simplify things down just to some really small components. In that case, it's just big yellow posts sticking up on a white domed surface. And a lot of the time, these are the sorts of things that really drive what I can do and what works best in what scale. Because there are other limitations I have as well. That's my colour palette. That is it. I can't mix those colours. I mean, I can dither them at a large scale, but I can't mix those colours together. I don't paint things. So I have a very, very limited palette of what I can do in terms of colours, which has a big impact on some of the buildings that I do. For instance, there's St Pancras. There's a nice close-up view of St Pancras as it looks now. Beautiful. I still absolutely love the building, beautiful building. This doesn't really work because it's on a computer screen, but hopefully you get the point. The main two colours in St Pancras are these two. There's that kind of sort of Midland brick colour, and then there's a I'm not sure what that's actually made out of. Something, cement or whatever, but there's a lighter colour for the detailing. But they're the main colours of St Pancras. The closest approximations I've got in Lego are bright red and a colour that we call tan. And the colour that we call tan actually is closer to the brick colour than the red is. But they are the closest colours that I can reasonably get in Lego in the quantity that's necessary. The colours that I work with are the current colour palette from Lego. Occasionally over the years Lego will go wacky and introduce all sorts of strange colours for about 1.5 years, and then those colours will disappear again, which leaves me with a palette of about 8 pieces in that colour. So, a complete aside, one of the models that I have been promising people I would build for years and years and years is Fab 1 from the Thunderbirds, the pink Rolls Royce. It's really lovely, I really, really like it, but until literally the last 12 months, the parts just haven't existed in pink to do it. The only pink we had was a pink from a female-orientated range about 30 years ago that had 16 parts or something like that. So I have to be very cognizant of what parts are available in what colour to enable me to build something. The interesting thing for me is that when I go ahead and build some Pancras in bright red and tan, it still looks like St Pancras. It's still recognisably St Pancras. The colours are, unless you've got the two right next to each other, correct. Because most of my viewers will not be looking at that building and going, well, that's a totally different Pantone colour to that, and that they don't see that. They just see the overall building. Very interestingly, I mean, I just showed a picture of St Pancras. What colour's the roof? It's not green. The roof is not green. The roof is more, there's an element of green in it, but actually it's Welsh slate. It's grey. So grey is actually a much closer colour combination to the roof. But I'm going to be honest, I prefer it green. It was green at one point, I'll give you that. So it's very interesting to me what people don't actually see. And I will spend a lot of time working on various models and trying to get them very exact. And I'm lucky enough to work with a very good photographer I share a studio with. And he will rein me in a lot of the time and go, it's a Lego model. Honestly, no one's going to notice. I will spend a day trying to get an angle to be 37 degrees instead of 40 or something like that. And I go, it doesn't matter. It's about the overall look of the thing. It's about generally what it looks like from distance, because my audiences and the general public are not that knowledgeable. You know if you've done something wrong. If something doesn't work and it's wrong, you know it's wrong, and Joe Public will know it's wrong and they will see it's wrong. But for me, there's an area, I've got an area of flexibility. I've got a big margin of error in a lot of things that I do, which I'm quite lucky to have. And the same thing comes up again with kind of repetition. This is an interesting thing that I guess comes up. If you're building, for instance, a housing estate, there are going to be a number of houses that are pretty much identical, give or take a few features. And perhaps you would be criticised for that. Certainly as a Lego modeler, if you're building something and you build multiples of the same thing, it's kind of seen as a lack of creativity. It's like, well, that's the same, but it's the same as this and that and the other, and they're all the same. But the thing that makes that a Georgian street is the fact that the four buildings are identical. So there has to be repetition within the model for it to work. St Pancras has vast amounts of repetition. It's one of the things that actually allowed me to build it to be such a big model in a reasonable frame of time, in that there was a huge amount of repetition, especially in the window structure. So from a distance, you're looking at the windows and you know, well, there's four distinct different levels of windows and four distinct different styles of windows, but there aren't. It's exactly the same window construction. And I know it's the same window construction because I've built hundreds of them. But it's the same construction of the window parts, of the colouring down the side and the columns, things like that. It's exactly the same. And it's that repetition that actually makes the building, in my eye, beautiful. It's that wide repetition. And repetition actually also helps me do deception, in that St Pancras is a Gothic building. Every window in St Pancras is Gothic arched. There are no Gothic arched Lego pieces. So there are no Gothic arched windows in my model. But what I do is a really just simple deception of overlapping two Norman arches to give me that Gothic point. So when you pull back away from it and when you look at the overall building, you see Gothic windows even though they're not there. Which is, a technique. It's one of a number of techniques I use that really help you cut the corners and actually get things done in Lego. This is a good one. Presumably you all know what that is. Yeah, it's the Cinderella's castle from the Magic Kingdom. And you probably know exactly what I'm going to say about it. It looks lovely, it looks like it's hundreds of metres tall. It's not. It's 58 metres tall. If you were to sort of work it out and go, oh, that's the height of a window, so the story must be about that height, do it by eye, you would come out with at least twice as many stories as are actually in the real building. And Disney are very good at this actually. Most of the Disney parks, most theme parks will employ selective compression. So if you're looking at a building in a theme park, the ground story will be the right height for people because you obviously have to walk in. But then you'll find that the first floor will be 20 to 30% smaller, the second floor will be 20 to 30% smaller than that. So the floors will actually get smaller as you go further away, and it tricks the eye into thinking a structure is much bigger and more impressive than it is. It's also why if you go to Disneyland, there are only a few occasions when you can actually get up next to Cinderella's castle. Normally it sits in the middle of a lake and you can't get near to it. And the lake will specifically not have features in it that let you judge scale. So that you can't tell that, for instance, unless a duck lands on it or something like that, but you can't tell that the window, wall you think over there is 10 metres high is actually only 5. Because Disney will specifically take things out of the scale that they're meant to be in, or they'll play with the scale, and they'll put little ducks on it that are half-scale ducks to trick the eye. They do this, and it's something I do as well. So again, going back to St Pancras, model on the left, real thing on the right. St Pancras is actually quite heavily selectively compressed to make it a feasible thing to build. Now, I like building in minifig scale because I want to put people in my models, because that gets kids excited when they go to shows and they see things like that, and people have a connection with it. But it's currently 2 metres wide. If it was actually 1 to 40, it would be 4 metres wide, it would be 8 metres long. It would be a ridiculously big building, A, to display, and B, to move. So I've compressed it quite heavily. I haven't compressed certain aspects of it, so the depth of the building, for instance, is correct. It's about, the building's about that deep, which is kind of roughly right. But what I've done is I've compressed the width of it quite strongly. In fact, the width is compressed by almost 50%. And what I've done there is I've taken, if you look on the real building here, between that main archway and the tower, there's basically a whole other section of the building that I've just taken out completely. Haven't even bothered to put it in. Haven't made an effort to make the windows smaller to fit them in. I've just taken the whole thing out. Because unless you're sitting over the two next to each other, you would never notice that. In fact, you might not notice that until I pointed it out. So I can use various techniques to make the scale manageable. The floors aren't big enough. If you stand a minifig next to the second and third floors of that building, his head will be poking through the ceiling. There's certainly no way on earth you could fit 2 floors of living space in the roof, which you can in the real building very, very easily. I've been inside and it's absolutely gigantic inside. So you can compress a lot of things down to trick the eye. And you can really, so in some circumstances, you can take it to extremes. So, this is a model of Central Park. It's got a couple of features in there that are really noticeable. So there's a hotel, sort of top left-hand corner, there's a famous hotel, Trump Tower, in the top right-hand corner. I can't remember the name of the skyscraper, but on the very left-hand side, there's a big toy shop in the basement. And I don't have a picture here, but if you view it from above, it has a rough layout of Central Park. But everything is extremely compressed. And lots of things are taken out, lots of the pathways just completely taken out, and it's just the main elements that are in there to give the eye enough to sort of navigate around what's going where. So it makes things, for me, possible, which otherwise wouldn't be possible. I do have one particularly interesting problem, which I'm interested to see if you get this problem in the real world, which is the angle of view of things. So this is obviously the Forth Bridge. It's very recognisable as the Forth Bridge. Here's my model of the Forth Bridge. Very bored-looking kid. Apparently kids don't like bridges. They're not that interesting. So here's my model of the Forth Bridge. Looks relatively similar. Except that first picture I showed you isn't really the Forth Bridge. The Forth Bridge, if you look at it on a plan view, if you've got a proper isometric projection of it, it looks like that. It's very, very thin. In fact, if you look at the second line down is a better example, the overhead view, it's extremely thin and extremely long. But even when you take my model, which is not as thin, not as long, put it up against the two, they kind of look similar, you get the similarity. The problem I have is that if I build my model to be correct, it looks wrong. If I build my model to be long enough and thin enough to accurately model a real bridge, it looks totally wrong. It's also, it would be that 6 metres long as is. It would also be, I think, to scale, that should be 13 metres long. Give you an idea of how much more stretched out it would look. But with the real bridge, you never really see that view. You probably see it if you're flying in, or if you're on Inchcombe Island or something like that. But even then, you wouldn't be able to see through the mist, and the weather wouldn't be good enough. You wouldn't get that view, that angle on the bridge. Whereas with my model, you only have to walk back, 5 or 10 metres, and then you've instantly got that angle, and it's really easy to see. So one of the things I find with a lot of the models that I do is that if I build it right, it looks wrong. And if I build it wrong, It looks right. So what I now tend to aim for is something that looks right, as opposed to something that is right. And unless it's a specific commission, unless it's like an architectural model of something, in which case it has to be as accurate as possible, I would tend to go for the look rather than the maths. Another good example of the Olympics. One of the things that I hugely stretched on this model was the vertical scale. Because for those of you that went to the Olympics or saw it on the TV, the stadium sits on a lovely island and there's rivers around the island and you can go walk down to the riverfront. And one of the ideas behind this model was to sort of replicate that it is parkland. It's a grassy parkland with wildflowers and things like that, and you can go up and down, and when you're there as a person it actually seems quite contoured, and you can walk off the paths and sit on the grass and watch a big screen and things like that. But on a 1 to 500 scale model, even a 10 metre difference in gradient level, you can't even see it. So the vertical scale on this model is completely out of whack. It's out. The buildings are fairly correct. The landscaping is just totally bonkers wrong. It's probably out by a factor of about 20. But not a single person has ever commented on it. Because it looks right. It looks like you should go down to the river, and the river goes under the bridges, which are trying to go towards the stadium. So it's a really good example of, doing something wrong that actually looks right. One of the things that I do have, I think, very in common with real buildings, though, is when it comes to strength. And there's a lot of techniques that I use which are, to me, eerily familiar to real engineering techniques. Things like foundations, cantilevers, and lamination of structure, and things like that. Of course, I have a problem that you don't have, in that my buildings need to do that. I need to pick them up and move them around. But then again, I don't need to worry about wind forces on buildings or earthquakes or anything like that. As long as my building can stand up to a 6-year-old poking it, with, looking at it with their fingers, then it's absolutely fine. But lots of the techniques that I use are very, very similar. This is a model, this is St Pancras actually coming out of Waterstone's bookstore in London. It's a good example of some of the techniques that I use. Now, my very first job was at a nuclear power station on the south coast in Kent. I was doing IT there, and apparently the whole building is built on a concrete raft. To give the things real structural stability. It's otherwise a shingle bed, so the first thing they did is laid an enormous concrete raft. I'm guessing pretty much like a foundation layer, but about 100 times bigger, much, much thicker. And I do a very similar thing with my models, apart from the fact that my main base plate is MDF, and I cut a bit of MDF, and then I do actually glue the base plates onto that to give it, structural rigidity to be able to be moved. But I need that base level to be able to build from to give it the strength. I also then you can probably see the thinness of those walls of St Pancras. They're about that thick in total, and that's the front-facing stone, all of the edging, capping, and the arches, things like that, and the windows, and the backing as well. Because my models are hollow, I have to back the windows so that you can't just see straight through them into a hollow building. For which, incidentally, I've never used black, because black always looks wrong. It's always a dark grey. So the walls are very, very thin, which meant that I needed to give those wall segments a big, solid foundation, which is why the white part you can see at the bottom actually sits below road level on the model. And it's not entirely solid, but a very solid chunk of Lego that gives it a lot of weight at the bottom, which gives it some real stability. It's not entirely solid because a solid Lego lump that big will crack. It needs a certain amount of flexibility to hold. The Mythbusters once did an episode on rolling an enormous Lego ball down a hill. I don't know if anybody ever saw a YouTube clip of Indiana Jones running through San Francisco following a Lego ball. It was about this sort of diameter made of Lego. And Mythbusters recreated it, and the first thing they found is as soon as you start to roll it, it'll shear and crack. Because a solid lump of Lego won't. The material doesn't like doing that. Conversely, if you actually made it a meshed internal structure, it would go on, be very happy. So I use that sort of technique to make my foundations. The other thing I do internal to a building is, again, because the walls are very thin, is I use exactly the same techniques you might use in a modern office block. So it has a steel, quote unquote, infrastructure. I obviously don't use steel, it's still using Lego. But a stack of bricks that high, if I build a wall of bricks that high with no structure to it, it won't last. If you knock it over, it'll smash, you won't be able to pick it up, it will bend far too easily. So what I use are Lego Technic elements, which A, are much longer, so I can get beams that are sort of that long, and also are much stronger. They have a stronger clutch power between themselves, so they connect together more strongly. And these vertical yellow pieces you can see are actually Technic structure that I put behind the walls, and they are then pinned through into the walls. So I'm using pieces in the walls that actually have pins that go into those Technic pins. And interestingly, actually, on the proper Lego geometry, they should fit perfectly without any stress, and they don't, because of the fact I've used lots of layers. It does alter the geometry very slightly, but what it does is it puts a compressive force on the wall. So you actually have to literally put your weight on the wall to get the beams to click in. But once they're clicked in, it's got a compressive force on all those bricks which holds it together. So those individual wall sections, whilst I was building it, you can literally pick up a section about that big by the top and swing it around, and it won't fall apart because it's got compressive strength in it. There's also a few other sort of, A-frames for doing roofs. Really basic building principle, but it works. It works just as well in Lego as it does in the real world. And if you try and do it in any other way, it'll be too heavy, it won't travel well, it won't resist, lateral or twisting forces or things like that. So you end up going exactly with the real thing. And this is, going back to the Forth Bridge, was one of the most interesting things I found. I built this model 4 or 5 years ago, something like this. It doesn't exist anymore, actually. It kind of sacrificed itself to become some Pancras. But I wanted to build the Forth Bridge because it's an iconic Scottish monument. I built a train already that I took down to London every so often. As most fans do, you build something you'll know well. So I built a bridge for the train to go over. And so it's about 6 or so metres long. And I had no plan. I had sort of rough blueprints that were the original blueprints that we used just from books and things on the bridge. So I was copying those, working out where I was going to simplify the model. There were fewer cross braces in it than the real model, things like that. But one of the things that I found out really rapidly was that the forces and the tensions and the stresses on my model are exactly the same as the real thing. So you probably remember that picture of sort of 2 people sitting on chairs with broomsticks and holding it out, demonstrating the principle of the cantilever. These bottom members at the bottom are heavily in compression. They're taking a lot of the weight, whereas opposed to the top members, which are in tension. And the way I built those various elements in Lego is completely different. The top elements are literally, they're long Lego bricks just with a brick top and bottom just to stop them falling apart. And under tension it works really well, but you could use a bit of string for that, or I could, because it's just a tensile force. The ones at the bottom are twice as thick, they're they're also double laminated. So I've got a layer of plates on the bottom and then a layer of bricks and then a layer laminated, another layer of plates on the top as well. So they're far, far stronger, far stiffer, because they're taking a huge compression force at the bottom, which is exactly what they did in the real thing. If you look at it, you can see. The other thing that I found out after I built this bottom right joint here has 6 connecting sort of pieces of steel, pieces of Lego in my case, coming into it. And they're all coming in at different angles, and none of them are multiples of 22.5 degrees, which is what I can normally work in Lego, because connectors exist for that. They're all coming in at wacky angles, they're all taking stresses in different ways. That one joint, which is repeated obviously throughout the model, but that one joint took me an exceptionally long time to engineer, to work out how to do it. And in actual fact, in the model, there's a slight cheat. If you look at the centres of where all those beams are going to, they don't connect. They connect slightly outwards because I just couldn't get the angles right to be able to take the weight of a working bridge, because this bridge does work. I mean, it takes trains across it quite happily, and it has done at public shows for days and days on end. Also takes my cats, as I found out when I was building it. So that part I found exceptionally difficult to model and get the angles right, and it was only after doing that I actually went back to my source material and I looked at the historical records, and that is exactly the hardest part that the steelworkers found to recreate on the Bill Bridge. They had exactly the same problem trying to do with all the stresses coming into a single point and then translating that into, in their case, foundations, in my case, just a whole bunch more Lego. So, unwittingly, I had gone through exactly the same process that the real builders had gone through. And you know, if I looked it up, I probably would have known it was coming. So, when I'm modelling Lego and building different things, I think, and I'm really interested in your feedback, that I hit a lot of the same problems that you have, but some that are very different, which I think makes kind of an interesting contrast. The nice thing going forward is, as was said, this is a kind of a burgeoning market for Lego. Although they had those Lego Modulex sets in the 60s that didn't do very well, the current Lego architecture range is actually doing very well indeed. There's quite a few of these sets, they're quite high priced, but they're very nice examples of architecture, and they seem to have a really broad appeal. So you know, kids like them because they look nice, kids like them because they've got complicated building techniques in them, adults like them because they're recognisable places they've been to and they can relate to them. We've got some here. There's also something which hasn't hit the UK yet, which is out in the US, which is Lego Architecture Studio. And this is really interesting because it's a big box. It's about the size of that Lego brick, and it's full of bricks. And we've got one at home. I didn't bring it because it's so blooming heavy, but it's absolutely full of bricks. That's the book that it comes with, but that's not instructions. There are not a single page of instructions in here at all. All that's in here are kind of examples of techniques you can use, some of the things we've been talking about here, repetition, things like that, patterns, you know, various ways of designing stuff, and a lot of information from architects that are building real buildings. And this is really the first Lego set that Lego have produced as a company that isn't either a fire engine or a spaceship or a car or something like that, or just a bucket of bricks with some suggested ideas. This is the first set that Lego have said, well, here's the materials, see what you can make from it. And they're really honestly saying that from this. And Lego have taken that out to various situations. So in the US, the Barnes & Noble bookstore chain are actually taking these Lego architecture boxes, opening the stores after the main doors are closed to the public, opening the stores, getting people in of all ages, and saying, have a go. Build something, build what you want to build as architecture, see what architecture you want to put into it. And the really nice thing is you don't need to tell kids to build things. You give kids bricks and they'll go and build stuff. So you don't need that upfront training to be able to get started, to get the bug, to actually start knowing what you want to do. And then these kids can decide if they want to take it on, take it forward as a career. So it's all, I think, looking really, really positive. Thank you very much for your time. You were all very quiet, very nice. But I'm sure I wasn't even looking at the watch, but I'm sure we've got a little bit of time for questions. Or feel free to come and chat to me. Thank you.
Going back to the Modulex stuff, why isn't Lego to scale in the first place? Because it seems a relatively simple thing to make it a metric book size.
Yes, it's a very interesting question. I honestly have absolutely no idea how they chose the geometry of the Lego bricks. It is, looking at the parts that are available and the variety of different parts and brackets available, it's a very, very clever geometry, looking at what's been done with it over the last 50 years. But obviously, when it was designed, it was just bricks. I really have no idea, to be honest. It's the only thing that I do know is that there was a precursor to Lego called automatic binding bricks, which was actually a British product, which are very. It wasn't that Lego copied the idea; it's that they're sort of independently co-developed, and they are exactly the same size as the automatic binding bricks. So Lego obviously took the dimensions from somewhere else, but where those dimensions come from, I have no idea.
Yeah.
There's bound to be some maths in there somewhere. There's bound to be some. The Christensen family are very, very clever.
So it's because it goes back to a lot of the idea of perspective and proportion, and you're talking about a lot of what you do, and then a lot of what we do as architects, how we visualize things and perceive things.
Yeah.
And it would just seem to be interesting if you did have a to scale Lego set.
Yeah.
And how that would affect things.
I don't know. I mean, it's not. The strange thing to me is it's not fantastically far off. You know, like traditional brick. It's not magically different, not massively different, but it is different. I really don't know. It may be something as boring as that's as big a brick as I could get in a machine. But no, I don't think anybody's ever found out. There's a lot of sort of dark past history of Lego that nobody knows, including the company themselves. The company had a internal museum, and it's actually very common that somebody from the fan community will go to the museum and donate them something or give them information, because like that they have no idea. They didn't even know it existed.
Who did you do the St Pancras model for?
Nobody.
Just because you liked it?
Just because I liked it. The real reasons, I built the hotel first in the train shed at the back. And my original thought was, for the last 2 or 3 Olympics, there have been a model of the Olympics made by the local Lego club. And at the time I was chairman of the UK's Lego adult fan club. And I thought, let's do the Olympics and let's do it minifig scale. Let's do it in the park, 1 to 40. You know, it's going to be absolutely massive. It's going to take millions of bricks. It's going to take years to build, but I'm confident we can do it. And one of the things I knew I would have to do is go to Locock and actually prove that it was possible, and prove that the quality would be there and it wouldn't look stupid, in effect. So I thought, what better way to start than with the station that the Javelins are going to go to go to the Olympic Park. So I originally built the hotel as a sort of proof of concept, with no intention ever to build the rest of the train shed on the back, because that would be stupid. The model would be 4 metres long, who would do that? So I built the hotel, toured it around Europe, took it to a few shows for Europe too, and everybody said, you've got to put the station on the back of it. And I just said no for about 2 years, and then I caved and built the rest of it. But no, it's a similar size to the Olympics, which was a commissioned piece. So I do things that large, but they're not cheap. Mm-hmm. And in terms of that, because it was a private model, was evenings and weekends as I wanted to do it, and it took best part 2 years. So, you know, as a full-time piece, you're probably looking at a good few months' work to build full-time.
Do people buy your pieces as a model?
I do a lot of commission work for people. So I have sort of two types of things I do. A lot of the models that are in the book, which will then go on to tour and things like that, I don't sell, so there's nothing being sold in the gallery shows. But the other half of the work I do is all commission based. So I would do, it can range from, I've done little gift giveaways, you know, that sort of big, you know, for clients at Christmas times and things like that, up to, I'm talking to Great on the Street at the moment, they have a big model, that sort of size, of their new redeveloped campus that they want to do in Lego, because it's great on the streets, kids, it works really well as a medium. And bigger, the Olympics would just about fit on that table, which was a commission build. So I do those and sell those, or it stays and goes on tour. It tends to be one of the two. I do some photographic commissions occasionally. So companies looking for PR, marketing, things like that, they want to basically take advantage of the fact that Lego's a really strong brand, and you know, put like a picture of something done in Lego has, in some cases, much more media appeal than a picture of the real thing. So I will do those and sell those,
So are some of the real ones, in place then in the exhibition, or is it more?
The ones in Paisley at the moment, it's 70 odd from the book, which are all real buildings or landmarks. There's things like a San Francisco cable car, which isn't a building, but it's a landmark. So they're all real things as well. We're opening next Saturday. They're actually opening a separate room as well, which is going to have two things in it. One is a public art piece where you can go and I do a lot of mosaic work because Lego works really well as mosaic. So you can go and build a piece of a mosaic and we're building a big Paisley pattern to go around the wall. The other part of that is 4 Paisley landmarks that I'm building for them. So they're going to be that sort of size. And what they're doing is they're actually putting in a rough layout of Paisley Town Centre. So they've got a table area, fairly large, with a rough layout with the roads and things like that in. And then the 4 real-life recognisable landmarks that I've put in are going into that. And they're asking members of the public, and kids particularly, to contribute to what they would like Paisley to look like. So there's a big building area, and they can build their own buildings and then add it into their version of Paisley. What that's going to look like at the end, I have no idea whatsoever. But it's nice. Yeah, I think it'd be imaginative if nothing else.
You mentioned that initially you were looking at doing a minifig size for the Olympic Park. That obviously changed.
Yes, I actually had backing from Lego to do it, and we were talking about 1.5 million bricks, which is not inconsiderable. I had a team of people ready to do it. We're probably looking at 50 to 100 builders over a 2-year period, because they would be doing it in their own spare time. I submitted it to the Olympic Arts Council, or the Olympic Arts, whatever it is, a scheme for arts-based projects that were running alongside at the same time as the Olympics. Submitted it to them. It did take a couple of meetings for them to get to take it seriously, but after I showed them some papers and things like that, they actually did take it seriously, and it went all the way up to local lawyers after about 8 months. And local lawyers, when it's blatantly Lego are not an Olympic sponsor yet. If they'd like to be an Olympic sponsor, we have no problem with doing it. So that project got canned entirely, and I actually thought it wasn't going to happen. And then about 6 weeks before the Olympics, no, actually a little bit longer, about 8 weeks before the Olympics actually happened, I got contacted by Lego in Denmark and the Danish Tourist Board, because they had a hospitality area with TV2, which is their national broadcaster, and they wanted to promote Lego as a Danish product. So they kind of said, yeah, that Olympic idea you had, could we do something about it? And we went through a whole bunch of different options about what we were going to do and what scale and all these sorts of things. And the original idea, because at one point it was going to be floating on a barge, and there was talk of a 400 square metre barge floating in St Catherine's dock that we would do this on, which would have been fab. But it turned out to be a 4 metre diameter pagoda that I had to stand in for 20 days. So we went through all sorts of different options, and realistically the only one that we could do was to shrink. We actually had a minifig scale stadium at the time. So I had an Olympic stadium that was about 4 metres, just under 4 metres wide. But really interestingly, it's boring as hell. The Olympic stadium, this is a cutaway model, so you could see half. It had a running track, but half the people was in there. And it sounded like such a brilliant idea, and then we built it and went, no, it's really dull. Because it is, really, it's just ranks, especially you're looking at it from one side, you've got ranks of seated people. You're looking at the other side, and you see big structural steelwork, A-frames, and nothing else. So we went through lots of discussions and basically said, right, let's drop the scale entirely. Let's show the fact that it's a park, and it's not just a bunch of stadiums of people sitting in them, and let's give people something they can work around. And it took a lot of convincing, actually, to get the Danish Tourist Board to go for that. I took them in a prototype model, just to give, probably the same way you would with real buildings, you do a prototype card model or something like that, and a very small piece of it. And I took in a piece of the stadium, which was literally that big, something like that, in cardboard, in a shoebox. It's anything I had to hand at such short notice. I went down for a meeting in London and said, this is what we're going to do, this is the scale. The stadium's going to be this big. And they really did look at me as if I was totally bonkers, because they just said, that's not exciting, that's not going to work, that's not interesting. And I really had to say, no, trust me, this will work. I know what I'm doing, this will work far better than the other ideas. But thankfully they went for it. And start to finish, we had 5 weeks to build not only the model, but all the staging that went on to get all the perspex boxes commissioned. Absolutely everything, 5 weeks from starting it to delivering it on the site. Which is not something I'd like to repeat.